In this video, we'll learn to use Cholesky decomposition. Decomposition is a type of factorization. So similar to how you would factorize a number, 3 times 2 is equal to 6, you can similarly factorize any matrix into two matrices. Okay, so for Cholesky decomposition, consider the following factorization. Let's take our stiffness matrix K and factorize into a matrix U transpose times the matrix U. Here U is our upper triangular matrix. So for a 3 by 3 matrix U, since it's an upper triangular matrix, we can write U11, U12, U13, 0, U22, U23, 0, 0, U33, right? So then the transpose of that matrix would be U11, U12, U13, 0, U22, U23, 0, 0, U33. Okay, and let's write our stiffness matrix K11, K12, K13, K1, K22. Let's call this equation 3. Okay, so now if you multiply U transpose with the matrix U, the first component you will end up with is U11 square is equal to K11. So if you know your matrix K, which you will, you can then find out each and every element of the matrix U. Okay, so then my U11 is equal to square root of K11. And similarly, you can find all the other components in terms of the elements of matrix K. Okay, so now recall our equation. K times X is equal to vector F, right? And substitute this into our equation here. So I can write U transpose times U times X is equal to F. Okay, I'm gonna give this equation number 5. Now we're going to do a trick here. We're going to call this some vector S. Okay, so from that I can write U transpose times S is equal to F. If I expand on this, U transpose is U11, U12, U13, 0, U22, U23, 0, 0, U33. Times the vector S, S1, S2, S3 is equal to vector F, F1, F2, F3. Okay, so if you see now, if you multiply these two, we end up with U11 times S1 is equal to F1, right? So U11 times S1 is equal to F1, which will give us S1 is equal to F1 over U11 without inverting the matrix, right? And similarly, we can also find S2 and S3 by forward substitution. Once we get our vector S here in our equation 6, we can then go back to our equation 5. So from equation 5, we can say that U times X is equal to our vector S. Now in this equation, we already know our upper triangular matrix U, and we know our vector S from equation 7. Okay, so similar to equation 7, if we expand, we can write so. This matrix U times vector X is equal to our vector S. Okay, this will give us U33 times X3 is equal to S3. So then X3 is equal to S3 over U33, and we can calculate X2 and X1 by backward substitution. Okay, so in this video I wanted to show you how a Cholesky decomposition can be used to obtain the solution to our vector X here without inverting our stiffness matrix K.